This is Pythagoras consult, basically on mathematics. We are to continue our class for JSS3, which I will also employ SS1 to watch this video because it has link with their topic. So let me call it. It's mainly for JSS3. So let SS1 also watch. So we call it number system. Although in JS3 they call it binary system. But if you look at their textbook, they have gone beyond number system binary. So let's recall some things here. We have done in the last class how to convert from base 2 to base 10, other base to base 10, and we just want to recall how can we convert from two bases. So let's say we are given, they said convert 313 base 4 to, let's say, base 5. So giving us this, so we all know that we are going to convert this first to base 10, and from base 10 we go to base 5. It's just like recall. So solution, we are going to have 313. We said base 4. I'll write the 4 under each of them. So the first one I'll put it to the power of 0, that 4. The second one to power of 1, then to power of 2. Then I make this one together. I put multiplication in between and addition with the next one. Multiplication in between. Then I put addition to the next one. Then multiplication in between. So meaning that 3 times 4 raised to power 2 plus 1 times 4 raised to power 1 plus 3 times 4 raised to power 0. So this one I will now have 3 times 4 raised to power 2 is 4 times 4, which is what? 16. So 16 plus 1 times 4 raised to power 4 plus 3 times 4 raised to power 0 is 1. Anything raised to power 0. So this one therefore will give us 16 times 3, that's 48. And this one give me 4, and this one 3. So finally we are going to have, this one will be 52, that's 55. We have 55 is 10. But this is not the end. We are going to base 5. 55 is 5. We are now going to convert it to base what? 5. 55. We are converting to base 5. We are going to divide it by that base. We are converting it to. So 5 in 5, 1. 5 in 5, 1. Remainder 0. We still use our 5. 5 in 11, that's 2. Remainder 1. Then we have 5. So in this is impossible. Then we write whatever is here down. So we read it upward. So when we read it upward, we are going to have 313 base 4 is equal to 210 base 5. So we'll now quickly move to, I think for SS1 we have done the addition, subtraction. So the addition, let's just give it an example under addition, as a recall, addition and subtraction. So addition and subtraction of binary, I'll just give one example. Like I told you that we are going to have it in that base. For instance, say 313 base 4 add it to 133 base 4. Their base has to be the same. If they are not the same, we bring them both to base 10 and add up. Then we leave it in the base that we are asked to. So let's move on. 313 add to 133. Both in base. We have base 4, base 4. So 3 plus 3, that will give us 6. How many 4 can we get there? 1. That one will be carried. We only write down the remainder. Then if we move further, it will remainder 2. And this one will give me 4, of course. 4 in 4 is up to the base. 1, it will remainder 0. This will give me 4. Sorry. This one will give me 5. So 4 in 5, and that is 1. Remainder 1. So this one too will give me 5. 4 in 5, 1, remainder 1, and the last one we write like this. So that's our answer. For subtraction, I have 1 and 2, 1, 3. Let's say please 4. Like I told you, the base must be greater than any of the digits. So let's subtract 133 base 4. So let's go. We have 213 base 4. Let's subtract this. So subtraction. There should always also be in base 4. We have 3 minus 3, that will be 0. It's not up to the base. 1 minus 3, of course, we know that we say it's not possible. We borrow 1 here. That 1 will go as the base. So this one will become 5. So 5 minus 3 is going to give us 2. So this one is 0. I may write it and I may not write. That is under addition and subtraction. And multiplication. Multiplication and division. Multiplication and division. So let's look at multiplication. The multiplication, I won't do ordinary binary. Let me do that the base other than base 2. So like I have 122 base 3 multiplied by 1 2 base 3. So they are both in base 3. I do our normal multiplication 122 base 3 and that one 2 base 3. Let's multiply. So 2 times 2, that will be 4. I can write down anything that is greater than the base. We'll apply it here too. 4, how many 3 can I get there? 1 and 2 remainder 1. So 2 times 2, 4 plus this 5. How many 3 can I get there? That is 1, it will remainder 2. 2 times 1, 2 plus 1, 3 is up to the base. How many 3 can I get there? 1, remainder 0. Then the last one. So I'm through with the multiplication of the 2. Then I go to 1. 1 times 2, give me 2. So I write on that is not up to the base. 1 times 2 and 1 times 1. Then I add. In the course of my addition, I'll still apply my base because I want it to be in base 3. So this gives me 1. This is 4. How many 3 can we get in 4? That is 1, remainder 1. So this one will be 3. It's up to the base. How many 3 in 3? 1, remainder 0. And this is 3, 1, remainder 0, 1. So this is my answer. Then let's look at solve this. They said base 2. We have to divide. For that class, I don't really want to stress them. Like I don't want to stress all the students. I normally tell them bring the 2 to base 10, divide and return it to base 2. So let's go with that first. So like I will cancel this and I will cancel this and I move on. If I'm converting it to base 10. So I have 1 0 1 1 1 0. So 2 2 2 2 2 2. So power 0, power 1, power 2, power 3, power 4, power 5. So this one is cancelled. Anyone with 0, I cancelled it out. So this one give me times 2. This raised to power 5, that's 32. So it's going to be 1 times 32 plus. So this one will give me 8. 1 times 8. This one will give me 4. If I multiply this one, 4 plus 1 times 4. And this one, 2 plus 1 times 2. And this one is out. So this one give me 32. Add to this. Add to 8. Add to 4. Then add to... No, sorry. The last one will be... Okay, I'm not talking about the last one. This one will be 2. So 2. So this gives me... this 40. So 46. 46 base 10. And this one. So I'll check out for this one. 1 0 0. So 2 2 2. Multiplication, power 0, power 1, power 2. So this one is with the 0. It cancel out. I only deal with this. I have only this 1 times 4. So all this one will give me what? 4. So since I'm dividing, I'll divide it. So I'll finally say 46. This is base 10 divided by 4. 146. It will not divide direct. So this question, I think, has issue. I don't want it to come in this form. Although we can divide it in senior class, that will give us that point or something like that. But I don't want it to be this type. So let's solve this the second one. So this one base 2 and base 2. So here we have 1. I want to cover this one to base 10. 1 0 0 1 1 0 2 2 2 2 2 2 0 power 0 power 1 power 2 power 3 power 4 power 5. So all these ones that I circled are cancelled. So this one we said to be to 5. 5 is 32. 1 times 32, add it to this one give me 4. 1 times 4, and this give me 2. 1 times 2. So we are now going to have 32 add to 4 add to 2. I think this will give me, this is 36 7 8. And that is be 38. It will be 38 base 10. 38 base 10. Let's move on. That is why I have issue with majority of the textbooks. The textbooks that I check those questions from, they are DST textbook, although I won't mention the name, but I don't recommend them. I don't rely on textbook. That's my own. I rely on what we can do. Textbook is nothing. It's just to check all this thing there and look at. I thought they should give me something tangible. So let's look at this. Yes, we have 1 0 1 0 0. I said I want to convert it to base 10, power 0, power 1, power 2, power 3, power 4. All these is zeros, I cancel them out. So it will remain this one. So it will be 1 times 16. That's 2 raised to power 4. Multiplication between. Plus, this is 1 times 4. 1 times 4. So this one will give me 16 plus 4. And finally, to give me 20 base 10. So divided by, this one give me 2 2. The zeros is cancelled. This one power 0 power 1. So this one is 1 times 2. And divide by 1 times 2. So divided by 2, 2 base 10. So we can now come and say 20 divided by 2. So this one will give me what? 10. This 10 base 10. Now I want to convert it to binary. So it will be 10, 2, 2 in 10, 5, remainder 0. 2 in 5, I think that is what? 2, remainder 1. 2 in 2, 1, remainder 0, 0, remainder 1. Then we write it upward. So if we divide it, it's going to give us 1, 0, 1, 0, base 2. So this will be our answer. So I prefer they bring it to both to base 10, then convert it to base 2. So now we are going to move to language. Yes, computer didn't understand ABC that we type. But we were wondering that how come computer didn't understand? Computer actually understand binary. So computer understand what? Binary system. So the computer understand binary system. That is what binary system is just 0 and 1. So how do we go about it? When you type A into computer, it will go register on a punch card or what is punch tape. So let's quickly go over it. Look at our A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z. So now let's now label them one after another. We have 26 alphabets. That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26. Now we have 26 alphabet. Take for instance, let me now give you how it works. Like in GS3 Beckett, they normally ask them. They just say you should convert, go to computer language. You have to convert go, just go. To write it in computer language, binary system. Then how do we go about that? We have go, which is what? Go. Let me first solve for G. G, let me look at G here. What is the number of G? This is G. G is what? 7. So I'll convert 7 to binary. So 2, that is 3 remainder 1. 2, that is 1 remainder 1. 2 is 0 remainder 1. So in binary, G is 111. So let me look for O, and let me look for O. O is the difference between O and 0 is 0 is for mathematics, while O is for English. Now it's 15. We have 15. 15. I'll convert it to binary 2. That will be 7 remainder 1. And this will be what? 3 remainder 1. 1 remainder 1 is 0 remainder 1. So this one in binary is 1, 1, 1, 1 in 4 places. So if I will put it on how you look at on a punch card that was called punch tape, how it looks like. It's going to be in this form, and dots. Let me write down. Dots represent 1, and blank blank space represent 0. So that's how it works on a punch card. We have, when like this one, we represent it to be dot. You see one dot there after the line, dot dot. So that's 111. So this one dot, one dot before, dot dot dot. So at this place now is nothing here. So that's how we represent it. We call it what? We call it punch tape. So that's how it's represented on there. So when computer see dot, it call it 1. So if I'm going to write go, go, go to someone, if I just say 111, I put comma 1111. You know that I said go instead of writing this. So you convert any letter there to binary. So we have done addition, subtraction, multiplication, division, and conversion of this into binary. I think for JSS3, this will be where we hang the boots. So have a nice time. Till